Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Younger Dryas in South America. This video discusses new evidence that supports the hypothesis that multiple cosmic impacts 12,800 years ago triggered biomass burning, climate change, and megafaunal extinctions in North and South America. The cataclysm was widespread and left traces in 4 continents. On March 13, 2019, a paper published in Scientific Reports described an extensive investigation of the Younger Dryas impact hypothesis by 16 scientists with backgrounds in many disciplines. The study examined a site in southern Chile at a latitude of approximately 40 degrees in the southern hemisphere. The scientists sought to determine whether the evidence at the Pilauco dig site is consistent or inconsistent with the Younger Dryas impact hypothesis and to explore the potential consequences of the proposed impact event. The image on the left is a shaded elevation map of parts of Chile and Argentina showing the regional setting of the Pilauco dig site. The red triangles indicate the location of volcanoes in the Andes Mountains. The map on the right shows the exact location of the Pilauco site within the city of Osorno in Chile. The Chilean Council of National Monuments has protected the Pilauco site as an important paleontological and archaeological resource because it has a rich and abundant assemblage of extinct South American Pleistocene mammals and cultural remains. The first excavations at the Pilauco site in 2007 followed the discovery there of a rich assemblage of mammalian fossils. To facilitate archaeological and paleontological investigations, the site was divided into a horizontal grid composed of 1 square meter elements, and the vertical sedimentary sequence was subdivided into stratigraphic units designated by PB6 through PB9. Pilauco's perilous porch platform poses problems. Steel beams appear to stabilize the foundation of the house adjacent to the dig site, but the soil under the back porch platform by the back door of the house has eroded, making the use of the porch dangerous. A dig site requires constant protection and maintenance because water, wind, and weeds can move material. This image shows water being pumped from one dig location into an adjacent pool. Vegetation also has to be kept in check because roots penetrate and disturb the layers of the soil. The strings that mark the horizontal grid are clearly visible. This image shows a photograph of the stratigraphic section of the west wall of the Pilauco site and the corresponding profile of grids 6 AD in the north and 10 AD in the south. The profile shows the abrupt contact between units PB8 and PB9. Young organic soil caps the sequence. The caption along the left vertical axis shows elevation above the site reference datum, and the caption along the right vertical axis shows the calibrated age. Once the researchers have a cross-section of the terrain, how do they know at what depth to explore? First, they need to take samples at different depths and obtain their dates. The graph on the left shows a Bayesian H-height model based on 16 radiocarbon dates. The horizontal axis has older dates to the left and younger dates to the right. The vertical axis has the elevation of the terrain. The plot of the dates on this graph produces the purple line. The vertical red dotted lines represent the age range of 12,835 to 12,735 calendar years before the present, which is the range for the proposed Younger Dryas impact event. The red dotted line intersects the purple line at an elevation of 550 centimeters. This is the layer that has to be explored. Bayesian analysis is used to produce robust statistical age models by calculating and comparing information relevant to dating, by identifying dates that are too young or too old, by evaluating clusters of dates, and overcoming some of the inherent biases of dating methods. In statistics, the standard deviation is a measure used to quantify the amount of variation of a set of data values. The Pilauco site had several types of microscopic spherules and fragments of impact, volcanic, and anthropogenic origin. The spherules were distinguished on the basis of their structure and chemical composition. The image on the left has iron-rich impact spherules that have distinctive dendritic surface texturing indicative of rapid quenching from melt temperatures above 1,450 degrees Celsius. The image on the right has calcium and silicon-rich basaltic volcanic spherules and basaltic glass fragments. Vesicular basaltic glass fragments are commonly found in all samples from the Pilauco site. These triangular diagrams describe the chemical composition of the spherules. The left bottom corner corresponds to pure iron oxide. The right bottom corner corresponds to pure silicon dioxide. The top corner corresponds to a combination of oxides of sodium, calcium, and manganese. Spherules containing iron and silicon with no sodium, calcium, or manganese are plotted along the bottom edge of the triangle. The marks in the middle of the triangle correspond to spherules containing equal amounts of all the components in all three corners of the triangle. These graphs show the changes in impact-related and environmental proxies according to elevation. The younger Dryas boundary shows peak concentrations of high-temperature impact spherules, chromium-rich spherules, and framboids. The term framboid is derived from the French word for raspberry, which describes the granular appearance of the structure under magnification. These charts show the stratigraphic distribution of megafaunal bones and dung fungi spores. The leftmost chart shows the occurrence of extinct megafaunal bones below but not above the younger Dryas boundary. The chart on the right corroborates the extinction by mapping the concentrations of spores of Sporormiella dung fungi. These spores act as a rough indicator of the number of herbivores in a given area. The spores disappear in the strata above the younger Dryas boundary for a long time until mother animals appear. The main objective of this study was to test the younger Dryas impact hypothesis by analyzing a wide range of data from the Pilauco site in southern Chile. The Pilauco study found results comparable to similar impact-related evidence found at more than 50 younger Dryas boundary sites in North America, Europe, and Asia. Identification of the younger Dryas boundary layer at Pilauco greatly expands the proposed proxy field to a distance equaling about 30% of Earth's circumference. Chromium-rich spherules are found in the younger Dryas boundary layer at Pilauco, but not found at the 50 other sites on 4 continents, suggesting that one or more local impacts or airbursts occurred in the chromium-rich basaltic terrain near Pilauco. In 2013, James Whitkey and 27 co-authors conducted one of the largest spherules investigations regarding spherules geochemistry, morphologies, origins, and processes of formation. Analysis in 18 sites across North America, Europe, and the Middle East found that approximately 10 million tons of spherules were distributed across 50 million square kilometers, similar to the well-known Australasian strewn fields and consistent with a major cosmic impact event. The 2019 paper by Pino et al. Expands the younger Dryas boundary field south of the Earth's equator and adds support to the hypothesis that several extraterrestrial impacts caused a great catastrophe and global devastation 12,800 years ago by finding chromium-rich spherules that are not found at other younger Dryas boundary sites. Pino's paper mentions the 31-kilometer wide impact crater found under the Hiawatha Glacier in Greenland in 2018. There has been speculation that the impact crater in Greenland may be associated with the onset of the cooling event 12,800 years ago, but the analysis of the ice layers of the Hiawatha Glacier indicates that the impact may have occurred during the Pleistocene between about 12,000 and 3 million years ago. Although the crater does not have a precise date, the potential age range of the impact event spans the younger Dryas onset. The mineral composition and the size of the crater indicate that the impact was most likely made by an iron meteorite at least 1 kilometer in diameter. Saginaw Bay has not been confirmed as an extraterrestrial impact site by petrographic analysis. Thus far, the only evidence linking Saginaw Bay to the younger Dryas extinction is the convergence of the elliptical Carolina Bays and Nebraska rainwater basins at Saginaw Bay and the conjecture that the saturation bombardment by secondary impacts of glacier ice may have caused a mass extinction from the Rocky Mountains to the east coast of the United States 12,800 years ago. The Iturralde crater in Bolivia has a diameter of 8 kilometers and a depth of 20 meters. Analysis of soil samples found large quantities of glassy spherules, which supports the hypothesis that the Iturralde crater may have formed during an air burst by a low-density extraterrestrial body. Estimates of the age of the Iturralde crater range between 11,000 and 30,000 years, which makes it a candidate for the extinction 12,800 years ago. The paper by Pino et al. Makes it clear that 12,800 years ago, there was a megafaunal extinction in South America similar to the one in North America, and that impact proxies such as microspherules have a wide distribution. The problem with the microscopic proxies is that they do not pinpoint the location of the extraterrestrial impacts. Much more research is needed to find conclusive evidence for the exact location of these impacts. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.